Okay, friends, let's get you some solutions to this homework from Randomness, the beginning of probability. The first three questions are pretty much just whatever you decided to answer to get you thinking about this idea of probability. So one and two, excuse me, are pretty much going to be pretty subjective to what your interpretation of what happened was. I'll talk about three a little bit. It's just kind of a fun question. It comes to me, I thought of it as I was recording the videos because my grandfather, way back in the day when I was tiny, used to play pick three in Delaware, back where I'm from. And you had to pick three digits between 0 and 9, and they had a drawing every night. So he would go to the bowling alley and buy a ticket every day. And every day he'd play the same number, 701, because that was my home address of my childhood house. And I remember when I was really young, I was really like 5, 6, 7, somewhere in there. And I remember asking him, Grandpa, why do you always play the same number? And he said, because you have a better chance of winning if you always play the same number than if you switch it. And that bugged the hell out of me. This is probably why I ended up studying math later in life. It bugged the hell out of me because it's not true. Now, he thought it was true because I think something happened. And again, this is going back 40 years of my life. I think he hit a couple times within a year, which is more than he should have hit. And I think because of that weird outlier experience, he thought there was something to his strategy. But here's the honesty. There's 1,000 possible numbers, 1,000, if you pick three digits from 0 to 9. That's using our fundamental counting principle from way back in the day. 10 digits for the first, 10 for the second, 10 for the third, 10 times 10 times 10 is 1,000. There's one winning ticket. So the chance of Grandpop's digits being the correct ones is 1 in 1,000. It's got to be 701 for him. The chance of it not being 701 is obviously 999 out of 1,000. But his claim that betting 701 is better odds than randomly guessing, you can see right away it can't be. He's only going to be right on average 1 out of 1,000 tickets, which means if he plays every day, once a day, over the course of about 3 years, he should hit on average once a year. So you can see if he hit twice within a year, his brain might say, wow, it's actually better to bet the same number, which is not necessarily true at all. If you were to randomly guess the number each time, you have the exact same chance because you're going to get the first digit right 1 out of 10 times. Assuming you get that one right, you'll get the next digit right, again, 1 out of 10 times. So now you're down to a 1 in 100 shot, 1/10 of 1/10, 10% of 10%. And adding that third digit in, it's 10% of 10% of 10%. So it ends up being 1 in 1,000. So whatever you put for number 3 was great. But mathematically, you can argue, and I think successfully, that it doesn't matter if you always pick the same number or if you change it randomly each time. I say, not mathematically, but energy-wise, it's better to just always pick the same thing. So Grandpa, I think, had a point, not the way he explained it. It's not that he has better odds, it's just less work. I mean, just pick the same number every time because it's the exact same chance. Why go through the effort of trying to be random? So anyway, that was kind of fun. Hopefully you watched the video. We're going to flip coins here. So let's see. I got my spreadsheets closed. We're good. Let's take a look at coin number 1 and see what this puppy dog flips for. Okay, so he's down there right now. Let's start flipping and see what happens. All right, he's starting to dance. He's doing his dance. All right, we're up to 150, 160 trials. Looks like it's starting to stabilize. Yep, starting to stabilize. Oh, look at this. Oh, look at this. Yeah. Oh, look at that right there. Yeah, it's definitely stabilizing. Yep. Now it's hard to know which line, because the penny's kind of large, but if you let it go enough times, it'll be closer to one. The middle of it will be closer to one line than the other. And I went back at one of your classmates' suggestions and added in 5% intervals here. So it looks like it's stabilizing at 25%. So your first penny was 25%, and no serious, hopefully no crazy secret. You could actually have moved this back and check the commands. So I have it generated random number between 1 and 100, and if it was less than or equal to 25, it was heads. So there's your 25% right there. I didn't tell you that, of course, because in statistics, you don't know that. The coin is flipping, so to speak, but you don't get to see how the coin is built. I wanted you to observe. That was the whole point, was to not let you know what was going on. So, all right, here's another coin. Let's take a flip. So, wow. Okay, this one's, well, at least at first glance, it appears to be way above 50%. Let's let it go ahead and do its little dance. Looks like it's trying to get up by 95, maybe down to 90. It's kind of hard to tell. We're going to let it run for a while. This is the point of statistics. The point of statistics is not to prove that you're right or prove that you're wrong. It's to observe a number of trials and see what's going on in the trials. And I believe this thing is stabilizing. And it appears to be stabilizing at 90%. 90%. We'll cheat. We'll cheat and look. Yep, 90%. But you didn't need this, right? You didn't need to see this. You needed to see this. And the more trials you get, the better the idea that that penny is stabilizing at the 90%. So good. All right. So I got 25%, 90%. Let's do coin 3. Let's see what this one is. All right. Here we go. Let's start flipping. Boo! Woo! Oh, wow. Okay. We're all over the place here. Oh, looks like it's hovering at 50. Oh, maybe it's just 50. Maybe I was a total jerk. No. I'm a partial jerk, but not a total jerk. It looks like it's trying to hug below that 50% line, actually. Might be settling on 45. Oh yeah, I think it's definitely, after 600 or so trials, I think it's definitely hovering down around 45. It's right below 50%. Yep, 45. There it is right there. Yep. I set them up to be nice numbers because I didn't want you to have to worry too much about splitting hairs about 44 or 46. So we got what? We got 25, 90, and 45. That's kind of fun. I enjoyed that. Hopefully you did too. I accepted quite a few answers as long as you were close for this one. I know we've had a lot of tech issues this term, so as long as you got within the neighborhood, I'm happy with that. Think back to the fair coin, the 50-50 heads one from the intro video. That's right. What does it mean that a fair coin flips with a 50-50 chance of heads? Now, some of you, I was a little bit mean on this one. If you put, it means you've got a 50% chance of heads. I mean, technically, yeah, but how is saying 50% chance of heads any different than saying 50-50? What does it mean? What does a 50% chance of heads or a 50-50 chance of heads mean? The first 50% chance of heads means that over a long period of time, 50% of the time, you're going to get heads. Listen to that again. Over a long period of time, when you flip coins, 50% of the time, you'll get heads. Notice I didn't use the word chance because you shouldn't use the word. If you're trying to explain the word chance, you don't want to use the word chance in the explanation. That's called circular reasoning. It's like saying something's round because it's circular. It's okay, but what makes it round? What makes it circular? It's the set of all points equidistant from a center. See right there? You don't use the word round or circle there. You define it. So 50-50, I don't exactly know where the phrase 50-50 came from. Some of you said, and this is how I interpret it, if you flip a coin 100 times, you can expect 50 of the results to be heads and the other 50 to be tails, which I think is a pretty cool way of looking at it. As long as you got the idea across that 50% of the time you're going to get heads, I was happy. So anyway, I hope you enjoyed this beginning of probability. This really is kind of fun. This is where the course, I think, takes a turn for the, oh yeah, this is the kind of stuff we think about all the time. Randomness, clumping, statistics, averages, probability, chances. And this is just the beginning. So let's I don't know why I just said I've reached the point in the term where I'm not even going to edit that out anymore. I'll catch you next time at Zoom and try the next homework. Hopefully it wets your whistle even more than this one did.